Okay, so in order to solve number 19, first we would have to start by looking for the moles of the unknown M. And we would start by labeling everything out. We know that the volume of M is 0.06 liters, the pressure is 3.07 atmospheres, the temperature is 30 degrees Celsius, but you have to turn that into Kelvin, and it'll be 303 Kelvin. We don't know the number of moles, and then the R is 0.0821 liters atmosphere over mole Kelvin. Then, in order to solve for M, we use the formula PV equals nRT. We isolate N, then N is equal to pressure times volume over R times T. So we do that, and then we find out that the moles of M is 7.40 times 10 to the negative 3. Okay, so now we're going to look for the moles of CO2 in the cylinder before it got heated. In order to do that, we use the formula PV equals nRT. We plug in the pressure, 37.2 atmospheres, and then the volume 0.060 liters over R, the constant 0.0821 liters atmosphere over mole Kelvin, multiplied by the temperature, which is 303 Kelvin, and then we find that the moles of CO2 before the cylinder was heated is 0.0897. Okay, so now we're looking for the remaining CO2. We gotta look for the moles of CO2 after the cylinder was heated. It's pretty much the same process. Label out the volume, 0.060 liters, temperature 303 Kelvin, pressure 28 atmospheres. We don't know the moles. And R is the constant. We isolate N, plug everything in, and we find out that the moles of CO2 is 0.0675. Okay, so we subtract 0.0897 mole CO2, which was the first moles that we found in the cylinder before it got heated. We subtract that to 0.0675 mole CO2 after the cylinder was heated, and we get 0.0222 mole CO2. And then from that, we use the mole ratio converted to just chloride. Mole ratio is 2 moles of Cl per every 1 mole of CO2. And then we get 0.0444 moles of chloride. And then from there, we divide that by the moles of M. Divide that by 7.40 times 10 to the negative 3 moles of M, and then you get 6 moles of Cl. We divide the moles of M over the moles of M, which will give us 1 mole of M. And the empirical formula is M1Cl6.